Now let's modify this equation a little bit. For the first first thing that I want to do is minus 1 by x cross integral x naught to x p of x over a dummy variable x prime x prime. So this is something that I have to evaluate. Uh, Introduce a dummy variable here because see your limit is x. So I don't want to integrate over x. Just putting a dummy variable. Okay, so this is going to be minus 1 by h cross p of x, you know, to mc, it is x minus x naught, and minus sign will be there. Okay, dx prime x naught to x. Okay, I just want to change this variable uh, x to y now. Before that, I'll extract all the constant outside. Minus 1 by h cross root 2m c is there, minus I'm keeping inside, integral x naught to x root of x minus x naught. So I want to find out uh, the relationship between x minus x naught and y. So something that I know is y is nothing but 2mc by h cross square whole raised to 1 by 3 x minus x naught. So give you x minus x naught as y h cross square divided by 2mc whole power 1/3, and dx will be obtained like dy into the same quantity. Hmm? Okay, so both we have to substitute here. X minus x naught is in root, so you'll be having y to the power 1 by 2 and 1 by 6 over there. So this is going to be minus y. Okay, as you know, inside this quantity this is prime. So all the y is also being integrating over y. Corresponding x value, what I am putting is y prime, x prime, because I want to put the uh, limit as y. Okay, so minus 1, yeah. Uh, root, what else is there? The constants which are coming out is uh, you have some h cross square by 2mc whole raised to 1 by 3. Along with that, that root, it will become 1 by 6, the root factor coming in. And also you have along with this dy h cross square by 2mc term coming, and also that integration over dy prime. So these are constant which has to go out. Okay, just no need to write it again. You can see a lot of cancellation here. Here you have 2mc to the power 1/6, and here you have 1/3. 1/3. This is 1/3. Huh? So when you add these two, okay, next one is cos root 2mc, and when you're putting these numbers together, it's like 1 plus 3 by 2. So it's just like h cross square divided by 2mc whole raised to 3 by 6. That will become 1 by 2. And you can see that h cross square raised to 1 by 2 and h cross both will cancel, and 2 root 2 mc and 2 mc that will cancel, and there is only minus 1 sign over there. And x naught corresponding to x naught, when from this expression, when x prime is x naught, you know that is going to be 0. So your y value is going to be 0 at that moment, and that will give you 0, and here I have nothing but y root minus y prime dy prime. What is this quantity? So there is no other constants now. This is minus 1. Integration of some y raised to 1 by 2. So 1 minus 1 raised to minus y raised to 1 by 2. Limit is 0, so directly transform that minus y raised to 1 by 2 plus 1, 3 by 2 divided by 3 by 2. So what you got is minus 2 by 3 minus y raised to 3 by 2. What is this quantity? I have seen this number here. 2 by 3 minus y whole raised to 3 by 2. So this is equivalent to your term minus 1 by h cross integral x0 to x p of x prime dx prime. With this whole quantity, instead of writing in terms of y, you can directly put this value over there. It will make our comparison easy because our general equation that we know is on this particular form. So the similar fashion we have to identify the components corresponding to y raised to minus 1 by 4 and whatever. So these things are over now. Yeah, 2 by 3 minus y raised to 3 by 2 is over. Similarly, you can find out 3 by 2 by 3 y raised to 3 by 2. What is that? So that is nothing but the right now we got negative value here, that will be the positive value. There is no other difference, so that can be identified. And another component that we have to identify is y raised to minus 1 by 4. So you can do the same way, just get the value and integrate and find out the value. So right now I'm not doing, I'll show you the value. This is like minus y raised to 1 by 4. You'll get it as 2mc h cross whole power minus 1 by 6 root p of x. This is a crucial thing that we want. Okay, and what is, and here another term which are present on the equation is y power 3 by 2 is there, which is nothing but 1 by x cross integral x naught to x p of x prime dx prime, and of course all the same like that. Okay, here there's it. Now just put these values in the equation and modify the entire equation. So the final equation of a and b with these quantities will be like this. Let's say y raised to 3 by 2, y raised to, sorry, minus y raised to 1 by 4. Just identify that term here. Y raised to minus 1 by 4. Here you have y raised to 1 by 4. So corresponding to this quantity y raised to minus 1 by 4, you'll be having what, 1 by root p of x term on your final expression. This is root p of x. As there is minus 1 by 4, it's going to be at the bottom of it. So, and the constant will be coming, and all those constant I'll combinedly take it as some other constant, and I'll give you the number, and the whole equation now will be getting modified into this fashion. So once we substitute all these quantities, then this is going to be the equation that you're going to get. So the final expression is going to be a of x is of this form. So on a classically allowed region, you will get the expression like alpha by root p sine of those quantities, as you know. And on classically forbidden region, it's an decaying exponential function. So this is a way AI is getting modified. And BI is also uh, similar, but it's a cost function in classically allowed region. Not that the classical regime you have always a sine and cosine function. They are real values. So there is going to be a sine or cosine function sort of. Uh, in the classically forbidden region, you have exponential function. So that is what you are seeing here. Okay, so another peculiarity here is that for your exponential, classically decaying exponential, you can see the amplitude quantity over here. So compared to the sinusoidal component alpha by root p, this is getting reduced by half of its amount. It's getting reduced. So decreasing exponential is having a change of this quantity into the half of the original value, whereas the increasing exponential component is not having any such sort of change. So that is the key observation. Alpha is nothing but the constant which are coming out of all the substitutions. So it's something once you are putting the numbers, you'll get it. So that is about AI and BI. Now, what is our aim is to compare it with the wave function that we know already. That general form we have written in the last class. So I'm not going to derive the things anymore. Uh, just giving you the result here. We have seen the general form. So WKB wave function we call that whatever we obtained. So for a classically allowed regime, uh, the wave function is of this form: a1 by root p, an exponential, which is a sinusoidal function here. You see, uh, complex number is there. So that is going to be a sinusoidal components, and we have also the exponential term on, yeah, the classically forbidden region. Okay, so our aim is to just compare it and find out the unknown coefficients. So for that, the entire expression here we have the expression in terms of sines and cosines. So I have to convert this expression uh, into these sines and cosines. So you just expand your exponential e raised to ikx sort of an expression, and you have another similar sort of function. So it's a linear combination of two sines or cosine. So you can use a summation expression and combine them and obtain the resultant amplitude and the corresponding phase or whatever. Now, what is going to be the change? You can substitute that value. So once you do that, your amplitude after the combination, it will become a new quantity, that is A, and you have a sine component as well as a cos component. So this is going to be the sine component you are going to get. This is going to be the cos component that you are going to get. So this constant is not going to be the same, and they will be getting modified in this particular manner. So how this pi by 4 is coming, put once you do the summation, you will come to know why, how they are connected, and of course you have to put the A like this. So this is a relationship which connects A and B, the new new A and B with the old A and B, or A1 and B1 here, A1 and B1. So once you know A and B, you will be able to calculate A1 and B1 also, because you have two expressions. Okay, so now how do we identify these quantities A and B? Well, just have to compare it with the expression over here. So here in the sign expression on the classically allowed region, I have the amplitude which is alpha by root B. And what about here? Here I have, in this expression, I have A by root B. So that means my A is nothing but alpha. Yeah, A is nothing but alpha, or A by 2 is alpha by 2. Okay, what about beta? No, what about B? Cos term. Again, that is going to be alpha. So A and B both are alpha for you, and you will be able to find out A1 and B1 by substituting that in this expression if you want. So what you are going to get for that quantity, your A2 is going to be alpha by 2, and B2 is going to be alpha itself. So this is going to be the value that you're going to get. When is this approximation method that we have done now is valid? The approximation, it's actually an approximation that we are doing here. We are taking oh, yeah, a potential of this sort, and this is the energy, let us see, and there are 2 points. Some way, due to the WKB approximation, we know the wave function over this region, and we know unforbidden region as also. I will call this 1, 2. This is my third one. Okay. So now what I have done is I found out the solution at this particular region, just zooming into this area and finding out corresponding that straight line what we obtained, corresponding to that we found out the wave function, and we found out the limit of that wave function when it is coming this side. So we know once it come towards this side, it has to match with the wave function which is that we already obtained. When it comes to this region, it has to match with whatever we obtained here. This side it has to match here, this side it has to match here. That is a reason that we have taken this kind of a scheme. So you know this is valid not just at this point, it's nearby to this region, right? Some area near the turning point where we have our now calculated value. Now suppose these 2 points are very close, they are very extremely close, then what happen? Then obviously your asymptotic limit, when you're taking, uh, you don't have much space to cover. See, if we are taking this region nearby to that point and another point comes very close to that, that limiting approximation will not work. We should have some significant separation between these 2 points of the order of minimum few times of the lambda at least.